The diagram shows the electric field pattern between two isolated point charges. So based on the field patterns around the point charge, right, we can conclude whether it is a positive or a negative charge. For this point charge, the field lines, they are going outwards. So it has to be a positive charge. And for this point charge, the field lines are going into the point charge. So it has to be negative. So with this, option D is the answer. A conductor carries a current of 2 ampere. And how long does it take for 10 coulomb of charge to flow through one point in the conductor? So we are given that the charge is 10 coulomb and we want to find out what is the time taken. Okay, we can use the formula I is equal to Q over T. So T is equal to Q divided by I. That will be 10 divided by 2. We have 5 seconds. Answer B. The diagram shows a circuit in which all the switches are open. So which switch positions would give a resistance of 6 ohms between X and Y? So the easiest way to attempt this question, right, will be to calculate the final resistance for each of the 4 cases. Okay, but for this video, right, I'm just going to show you the correct answer. So the correct answer here is B. Okay, when switch 1 and switch 2 are closed and switch 3 is left open. So this is how it will look like. It becomes a parallel branch of 2 3 ohm resistor, and after that the current will go through the 4.5 ohm because S3 is open and it is an open circuit. Okay, so to calculate the total resistance, we just need to calculate what is this parallel branch, and then we add to this 4.5 ohms. Okay, so this is how we can do. 1 over R is equal to 1 over 3 plus 1 over 3. So 1 over R is equal to 2 over 3, and we need to flip this over to find R. So we can say that R is equal to 3 over 2, which is 1.5 ohm. And for a series, for 2 resistors in series connection, we can just add up the resistance. So 1.5 ohm plus 4.5 ohms, we will get 6 ohms. Answer B. Okay, the terminals of a battery are joined by a length of resistance wire. So which change increases the current in the battery? So we might want to look at the relationship between current and resistance. Current is inversely proportional to resistance, meaning the higher the resistance, the lower the current, and the lower the resistance, the higher the current. Okay, so now we look at the options. Option A, connecting an identical wire in series with the first one. This will increase the resistance. It will cause the current to decrease. Increasing the temperature of the wire. As temperature increases, the wire, being a non-ohmic conductor, its resistance will increase. So this will cause the current to decrease. Option C, using a shorter wire of the same material and the same thickness. Okay, we know that the resistance of a wire is directly proportional to its length. So if you use a shorter wire, that means the length decreases. It will cause the resistance to decrease. This will cause an increase in the current. That's why C is the correct answer. And option D, Using a thinner wire of the same material and the same length, the resistance of a wire is inversely proportional to the cross-sectional area. So using a thinner wire, you are decreasing the cross-sectional area. You cause the resistance to increase and the current to decrease. So D cannot be the answer. Okay, in which circuit does the ammeter read 2 ampere? So let's recap. If I have a current of 3 ampere flowing into a parallel branch, the 3 ampere will be split up into smaller current in each branch, and after that it will merge back to give the original current of 3 ampere. So how the current will be split up, it depends on the resistance in each branch. Okay, now let's look at option A. 3 amperes comes in, so I have 1 ampere here and 1 ampere here. So the current in the last branch, it has to be 3 minus 1 minus 1. That will give us 1 ampere. Option B, it should be 4 ampere minus 1 minus 2. We have 1 ampere as well. Option C should be 5 ampere minus 1 minus 3. So I have 1 ampere. Option D, 6 ampere minus 1 minus 3. I have 2 ampere. So 2 amperes will be resisted in the ammeter in option D.